Good morning, folks. I'm going to kind of pick up where we left off yesterday with matrices. I kind of hinted at the idea when you're multiplying two matrices and you get that 1, 0, 0, 1. They are what's known as inverse matrices. So today's video is going to be a little bit about finding what an inverse matrix is, or how to find that, and then how to also use it in your benefit. So the good news is we're going to keep things very simple. There's a different formula for every size matrix, and we're going to keep, believe it or not, as complicated as this is the simplest case of an inverse matrix. So for a 2 by 2 matrix, if I have matrix A given to us and it has all four elements A, B, C, D in that order, this is how we would find the inverse of A, which is A inverse, that little -1 symbol. So there's two things you need to do. This fraction here, this is kind of like a coefficient. So we're going to take this number and we're going to distribute it into this other 2 by 2 matrix. And that's the second part. This other 2 by 2 matrix is a manipulated, restructured matrix. So there's two things happening. Elements A and D in the original matrix trade places for the inverse matrix. And elements B and C, they stay exactly where they are. However, they become negatives, or opposites, I should say, of their original values. Okay? Once you move things around here, this coefficient, whatever this coefficient comes out to be, is then distributed into these four new terms. Okay? So the coefficient is going to be a 1 over AD minus BC. So those are the A, B, C, D terms of the original. Now, if that denominator ends up being 0, then that just means there's no inverse that exists. So not every 2 by 2 has an inverse. All right, and the way we would know instantly if it does or does not is looking at this denominator. So let's kind of just see this in practice. So here I have a 2 by 2 matrix A. We're going to find A inverse. So the first thing we do is we want that coefficient value. So 1 over AD minus BC. Well, AD is 1 and -9. B and C are 2 and -4. So it's 1 over that cross multiplication there. I'm going to just rezoom here because it looks a little blurry. There we go. And it comes out to be -1 when all is said and done. So what that means is this -1 goes in front, and now I have to do some manipulation going on here with my matrix. So again, A and D trade places. These two terms are opposite positions where they were originally. And then the B term becomes the opposite value. So it was 2, now it's -2. The C term, same thing. It was -4, now it's +4. And the very last step is whatever this coefficient was that we first calculated, that's going to distribute to all four entries. So that's why, once again, they're all becoming opposites again because we're multiplying that negative through. So here, this 9, 2, -4, -1, this is the inverse matrix of the original A matrix. And just a comment real quick, if you're ever unsure, am I doing this right? Is my answer correct? There is an easy way to check if you did this correctly or not, and you simply take the product. So we saw this in yesterday's video, where if I have two matrices and they multiply to give me this special case, this 1, 0, 0, 1, then they have to be inverses. So we had the original, we found what we think is the inverse. If we multiply them, we do in fact get this 1, 0, 0, 1. So that's just showing, that's a quick check, hey, I did this correct. Okay, now quick note, this 1, 0, 0, 1, this is kind of like the matrix equivalent of the number 1. This is called the identity. This is basically canceling it out to a neutral number. If you think about the regular number system, like 1/3 and 3, when you multiply those, they're inverses and they give you 1. This is like the matrix 1. Okay? Now, let's do one more problem. This is actually going to be the last problem of the video. And it's basically using an inverse. Why do we care about these inverse matrices? When would we ever need to cancel out a matrix with its inverse? So in the very first lesson, we did an addition and subtraction in a matrix equation. Now we have multiplication. We can't divide matrices. So I can't just like divide A and cancel this out and solve for X. That's where you're using your inverse. So the question is, we're going to solve for X in this matrix equation, and we're given A and we're given B as two other matrices. So as a quick thing you want to just consider, you don't have to do this, but it's a little bit of reasoning. If A is a 2 by 2 and B is a 2 by 1, multiplying these two A and X together and getting B, we can figure out the exact dimensions of what X has to be. Keep in mind, the inside numbers have to match, so this has to be a 2, and the outside answers give me this matrix dimension here, so that would have to be a 1. So I know X is a 2 by 1 matrix. Now, okay, that's information, but that's not really solving for X. That just tells me the size of it. So now what we're doing is, in this little equation, we had AX equals B. I want to cancel the A, and that's where I'm going to multiply it by A inverse on the left side. So that's going to cancel out A, which I have to keep it balanced, so I'm going to multiply by A inverse on the left side again. And what I just said in the first piece of paper was, if I have a pair of matrices that are inverses, they multiply to give you this identity, this 1, 0, 0, 1. Now, I don't need to see this step ever, but I'm just emphasizing that these things technically don't completely disappear. They give me this thing. This thing is the matrix equivalent of 1. So the identity, or 1 times X, is just going to be X. On the right-hand side, I'm not really changing anything straight through because we've now solved for X. So A inverse times B, whatever that product is, that's what's going to find us the value for X. So we need to first find A inverse, because the problem gave us B, we need to figure out A inverse. So that's where we're going to revisit our formulas. Again, here's my A matrix, so this would be like little a, B, C, D. So that's what I'm finding here. First, I'm going to find my coefficient for the inverse equation. And you can kind of see step by step, it ends up being 1/2. Yes, we are going to have fractions. So we put the 1/2 in front, and again, we have to do some restructuring. So the A and the D trade places. The B and the C become opposite what they were over here. When I distribute the 1/2 through, we have a couple fractions ending up. This is a -3/2. I don't know if you can see that with my handwriting. This is your final inverse A. Well, we're almost done. This is probably one of the longest problems you're going to see with matrices. We wanted X. We didn't want an inverse. So we now take that inverse of A and we're going to multiply it by B, and whatever that answer gives us, that's my final value, or I should say values, for X. And that's what we're seeing here. So X is A inverse times B. So here's my A inverse carried down. B was given to us in the original problem. We multiply through like we learned in yesterday's video. So again, we're just going to straight through. Now, we have some nice answers here. I was a little bit inconvenient with the fractions temporarily, but the final answer was 8 and 5, which, again, going back here, we knew it was going to be a 2 by 1 matrix, and this kind of confirms that. So there's a little bit of connection you can make step by step to kind of reason your final answer. And once again, there's the final, I should say, value for X, because there's only one matrix. Now, I'm going to leave that there. We covered every major topic. We have one last activity where I don't want to really go into a new chapter before spring break, so I'm going to extend matrices through the end of the week. I am going to give you a graded Google form, likely on Thursday, but I'm going to do some groundwork for an activity that we're setting up for Friday. The activity on Friday is not graded, but it is something that's a nice little lighthearted use of matrices here. And the graded Google form, it's really only going to be a handful of steps. and I keep saying Google form. What I think I'm going to do is what I mentioned yesterday is taking pictures of work and just emailing that or sending that to me by the end of the week. More information on the post, though. All right. Have a good day.